Introduction to solving equations. What is an equation? In mathematics, an equation is a statement that asserts the equality of two expressions. The two expressions are connected by an equal sign. That's an equation in mathematics. We can compare an equation to a balance scale. Let's say we have the equation 1 plus 1 equal 2. Well, it turns out that just like in a scale, we can perform any of the four basic operations: addition, subtraction, multiplication, or division, as long as we do it in both sides of the equation, so that if we refer to the scale, so that the scale remains balanced. The same way, the equation must remain equal. So that's why we have to perform the operation in both sides of the equation to preserve its equality. So let's say we add 5. We can add 5, but then we must add 5 to both sides of the equation to preserve the equality. Let's go back to this concept of a scale, a balance scale. We use a balance scale as a metaphor for an equation. Let's say that we have a scale and that we want to balance that scale. Here you have a scale that has two squares and a triangle on the left side, and it has a triangle on the right side. As you can see, the scale is not balanced. It's tilted to the left. So what would you add to the right side of the scale in order to balance it? So we have on the left side a square and another square equal 2 squares plus a triangle. That's on the left side. On the right side, we just have a triangle. So if we add 2 squares to the right side, then the scale will be balanced. Again, we are using a metaphor of a scale for an equation. Look at the scale and notice that it is balanced. So if the scale is balanced, what can we infer about the quantities, about the weight of the square, the triangle, and the rhombus? Let's think about it in another way. Think about it this way. We know that the scale is balanced. We also know that both sides of the scale have a triangle. So it stands to reason that if we remove the triangle from both sides of the scale, it will still be balanced. Therefore, we can infer that the square and the rhombus have the same weight. They are equal in value. This is the same concept we use to solve equations. We can add and subtract from both sides of the equation as long as we make sure that we do it in both sides of the equation, so that we preserve the balance, so that we preserve the equality between both sides of the equation. What is the value of the unknown? Suppose we have the equation n plus 2 equal 8. In this equation, you probably know that n must be equal to 6. That is because if we substitute n for 6, we can easily see that 6 plus 2 is equal to 8. When we are solving equations, we have a method, a procedure that never fails. We call this method, this procedure, solving for the variable. It basically means that we're going to isolate the unknown. We're going to isolate the variable. Let's say we have the equation n plus 2 equal 8, and that we want to use this method, this procedure, to solve this equation. Well, then what we have to do is undo the addition, the plus 2. We do this by performing the inverse operation for addition, and that is subtraction. We are to subtract 2 from both sides of the equation. We need to do it from both sides of the equation, again, to preserve the equality. If we subtract 2 from both sides of the equation, 2 minus 2 equals 0, and 8 minus 2 equals 6. So that we get n plus 0 equals 6. 0 is the identity element for addition. What that means is that anything we add to 0 will be equal to itself. So n plus 0 is n. So we have that n is equal to 6. The same can be done when there is a multiplication. Suppose we have n multiplied by 2 equal to 8. If we want to isolate the variable, solve for the variable, then we do the inverse operation of multiplication. We perform the inverse operation of multiplication, which is division. And we divide by 2 on both sides of the equation. Remember, we have to do it in both sides of the equation to preserve its equality. Then we have that 2 divided by 2 is equal to 1. And 8 divided by 2 is equal to 4. Now, 1 is the identity element for multiplication. This means that everything you multiply by 1 remains unchanged. So n multiplied by 1 is equal to n. And we have that n is equal to 4. This is how we isolate the variables in addition and multiplication, by performing the opposite operation in both sides of the equation.